In this video, I'm going to show you the connection between grad f, position vector, and velocity vector for a given surface. So punch this surface in GeoGebra 3D. So that will then give you this surface here. We are looking at this specific point here, 3, 4, and 5. So 3 across, 4 in the y direction, and then 5 up in the z direction. So once you've been given this surface, you have the option of entering the 3D world or the 2D world. We will look at this later. Let's tackle the 3D world first. So rewrite the equation in this form. So luckily we're already in this form because this is a constant. This is a constant. You can do whatever you want with x, y, and z. We're doing whatever we want with x, y, and z. So we are already in this form. So to compute grad f in 3D, we will deal with 2D later on. So in 3D, you would take the partial derivative of this with respect to x. That will then give you this. And then with respect to y, that will then give you this. And then with respect to z, it's just 1, which is this. So our gradient vector is given by this. And I'm expecting you to be able to do this by now. And then we need to evaluate it at precisely at this point here, 3, 4, 5. At this point here, 3, 4, 5. So we would put this into the x, this into the y, and this into the z. But there's no z. So it just remains as k. So this is our grad f. This grad f here, this vector here represents grad f. So you would jump to GeoGebra 3D, and then punch a vector in. So you would draw your surface by doing this, and add in your point. This is our point here at A, and then you need to define our gradient vector. This is our gradient vector. The syntax is that you have to use double brackets, so be careful on this thing. So define your vector grad f. So we've already done that. Now you need to draw the vector from our point to this point here. So this point is a plus, well, figure it out for yourself. This is our vector here. So notice that our vector, our grad f, points straight out from the surface. So that's grad f in 3D. So now going back to here, hang on. So when given a surface, you can compute grad f in 3D, and you can also compute grad f in 2D. But let's now enter the 2D world. So what that means is at this point here is at an elevation of 5. So let's look at the elevation of 5. So imagine you've got a horizontal sheet of paper at an elevation of 5. So you're slicing this surface. You're slicing it at an elevation of 5. So it will give you a level curve looking something like this. Something like this as an elevation of 5. So we would put this 5 into the z. So this whole thing here will then become this. So now we're entering the 2D world. When you slice it at an elevation of 5, it will give you this ellipse, and then you would put 5 into the z. So that will then give us this. So now take away 5 from each side, and then divide everything by 5. So this will become 45. This will become 20, and this is 1. So because it's equals to 1, it's easy to understand our equation. We know that this is going to be root 45, and this is going to be root 20. So from here we can punch this into Desmos. So hang on. I will continue in the next video. Okay.